Okay, so we've already talked about friction, where friction allows electrons to jump from one object to the other. And we use the electrostatic series to determine which object becomes positive and which becomes negative. Now we're going to talk about conduction. Conduction is when we have an object that is already charged in addition to another object that's either neutral or charged. And it doesn't matter what charge these objects have when we're talking about conduction. What matters is that these two objects touch each other. That's the big difference. Conduction, in this case, means touch. So two objects, one is charged, one may not be, they touch each other. So down here, I have a few examples, but what's really important to know is that electrons are going to move. Okay, so electrons move, and they like to spread out. These electrons like to spread out. The analogy I always like to use is think of a city bus. Have you been on a city bus before? So when you walk onto the city bus, you have to not be that person. And what that means is when you get on the bus, you spread out. You find the space in the bus that is the most empty. You never go and sit beside someone who's already there. So electrons are just like people on a city bus. They're going to spread out as much as possible. And when the doors of the bus open, they're going to leave and spread out. So electrons are a bit like people on a city bus in that they like to spread out as much as possible. So when we're talking about conduction, electrons are moving, and when you're trying to figure out where the electrons are moving, you need to think about it logically. Electrons are going to spread out as much as possible. Let's look at our first example. In our example, we have one object that is negatively charged and another object that is neutral. When we touch this object that's negatively charged to the neutral object, these electrons are going to spread out into that neutral object. When we remove that first object, they're both negative. Notice they're both negative, but our initial object is less negative than it started out being. So there's only 3 negative symbols here compared to, 10-ish. And some of those electrons went here. So the electrons don't just disappear, they go somewhere. So they always exist, they don't disappear, they're always going to exist in one of the objects, but they do spread out. So we're left with 2 negative objects. One of the objects is less negative than it was before. One of the objects is more negative than it was before because it started out as neutral. Okay, here's our next example. We have a neutral object over here, and we bring a positive object close to it. If we have a positive object and a neutral object, then this neutral object is more negative than the positive object. So the electrons are going to want to escape out of this object and into the positive object. And that's exactly what they do. So the electrons jump from this ball thing and into this other object, and this causes this object to become less positively charged. Notice there are 6 positive symbols compared to, 12, 15 positive symbols. And this object now becomes positive as well. So we're left with 2 positive objects here. Okay, here's our next example. Here we have what's called a pith ball. A pith ball is basically a lightweight ball on a string attached to a pole. So this pith ball hangs out and it's neutral. I bring over a charged rod or object. It doesn't matter what the charge is. A neutral object and a charged object will be attracted. They can then touch, and over here I've used an example of a negative object. Often we use an ebonite rod, which is why it looks like a rod. And so they've touched each other, and this is charging by conduction. Now, as we've talked about, the electrons are going to move. Pause the video now. Can you guess where the electrons will move? Will they go into the pith ball, or will they go into the rod? So now that you've paused the video, if you guessed that the electrons would move from the negative rod into the neutral pith ball, you were correct. So now we're left with a pith ball that's negatively charged and a rod that's negatively charged. And of course, these two objects are now going to repel. So this pith ball would swing over this way, because remember, it's dangling on a string. This is an object that we call an electroscope. This exists in real life, and this is just sort of my little sketch of it. So we call it an electroscope. Electroscopes are neutral if they're just sitting there, and they have these two little very light sort of leaves is what we call them, like a leaf. These leaves are made out of things like aluminum foil or other very light metals. So what we can do with this is we can check the charge of objects. So if we have, here's our ebonite rod again, and if it's negative, and we charge this electroscope using conduction, remember that's touch, so these two will touch. Can you imagine where these electrons will go? Will they go into the electroscope, or will they stay there, or will these electrons go here? Okay, so what I've drawn here is another electroscope with our ebonite rod touching the electroscope. What happens is, because our electrons want to spread out, they enter the electroscope. And then because there's all this space down here, they actually spread out more. And they spread out and go down into the leaves. Because we have two little leaves right here, both with a negative charge, these leaves are going to open up and spread out because like charges repel. So this tells us that our original object was charged. Okay, over here I've set up another example, but this time instead of negative, it's positive. Where do you think the electrons will go? What do you think will happen to these little leaves? Will they attract each other, or will they repel? Pause the video and take a guess now. Okay, did you stop the video and guess? Well, electrons want to spread out. So they're going to go from the neutral object and into the positive object. If electrons are leaving, then that means that these little foils will become positively charged, which means they're still going to spread out. So we talked about charging by conduction together, and we went over differences between positive and negative objects and where electrons are going to go. We also talked about an example with a pith ball and also an example with an electroscope. The important thing to remember is that you have to think like a passenger on a bus. Where are those electrons going to go in order to get the most space?